Alright, hopefully this is the last video right here, number 44. Let's finish this review. I'm proud of you that you've gotten this far. What would I do? Step one is I'm looking to factor this. So I'm going to factor out a negative 2. That gives me x squared minus 16. I'm going to factor out an x. That gives me x minus 4. Then I'm going to continue to factor. So x squared to take away 16 is the difference of squares. That x plus 4x minus 4. And then I want you to recognize that there is a hole in the function. So we're left with negative 2, x plus 4 over x. All right, so what are the things I'm looking at now? So the x-intercept's at negative 4. We have an asymptote, a vertical asymptote at 0. So we have two numbers that x can't be, 0 and 4. The x-intercept is at negative 4. The y-intercept, we have none. And the reason is we have an asymptote over the y-axis. There's no point there. The vertical asymptote is at 0, I said. We have a horizontal one. So negative 2x squared and x squared, that's negative 2. So we have a horizontal asymptote at negative 2. We have a hole. And so what we crossed out, there's a hole at positive 4. And then to find the y-coordinate, I plug in positive 4 and solve that. So this is going to be negative 16 divided by 4. That's negative 4. So there's a hole at 4 and negative 4. There's negative 4 right there. So 4 and negative 4 is where the hole is at. And we have enough to draw this. So there's one part of the graph. Here's the other. All right, turn the page. Enough graphing for now. Can you simplify radicals? Let's see if you can simplify these. So we have to know our times tables are perfect squares. For 72, we write that as 36 times 2. And k to the fourth, we need an even exponent, which it is. So the square root of 36 is 6. And multiply negative 2 in front, that gives you negative 12. The square root of k to the 4 divided by 2 is k squared. And then what's left that's prime is 2. That's it. The square root of 64 is 8. So it's 8 times negative 5, that's negative 40. M is prime. 32 can be written as 8 times 4, and then n can be written as n cubed times n. And then the cube root of 8 is 2 times 5 is 10. The cube root of n cubed is n, divide by 3. And then what's prime and left behind is 4n. The cube root is 125 times 2. And so the cube root of 125 is 5, times 5 is 25, and then 2r squared is prime. Oh, there's a little 3 there. Adding and subtracting, we first have to simplify it. So 24 is, 4 times 6. So the square root of 4 is 2, times 3 is 6 root 6. This is 9 times 2, so the square root of 9 is 3, times 3 is 9 root 2. This is, what do I got? So this is 9 root 2. 8 is 4 times 2, so the square root of 4 is 2, times 3 is negative 6 root 2. Making a mess of this. So 6 root 6, there's no like radicals for that. But root 2, we have negative 6 plus 9, so that's positive 3, root 2. Done. So the key is to simplify it and then match up what matches. Here, there's nothing to simplify, so what matches is 2 and 2, that's 4 root 3, and negative 2 root 5. Here, the first two are prime, and then the last one is simplified using 8 times 3. So the cube root of 8 is 2 times 2 is 4 cube root of 3. Now which one matches and which doesn't? So we have the cube root of 2. We have 4 take away 1. That's 3 and the cube root of 3. Alright, simplify it. We just simplified this one. So again, that's 8 times 3, so that's negative 2 cube root of 3. This one is 8 times 2. So again, the cube root is 2 times 2, which is 4, and the cube root of 2. Same one here, right? So again, 8 times 2, 4 times 2, same as the exact one, 4 and the cube root of 2. So only the cube root of 2 can be added. The cube root of 3 is a different cube root. So that's 8 and the cube root of 2. Multiply. So root 10 times root 10 is 10, and negative 2 times 10 is negative 20. 10 times 5 is 50. It's negative in front. That's 25 times 2, so that's negative 5 root 2. This one we're going to have to FOIL. So that's root 2 and root 3, and we're going to multiply it out. That's 2. That is root 6. This is root 6, and that's 3. So if we add that together, I get 5 and 2 root 6. Again, I'm going to have to FOIL. So I have 2 root 3 times 1 and negative 5 root 3 and negative 4. And I'm going to multiply it out. That's negative 10 times 3. This is negative 5 root 3. This is negative 8 root 3. And that's negative 4. So that's negative 30 and negative 4 and negative 8 and negative 5. And you have your answer. 57. The square root of 25 is 5 and the square root of 4 is 2. Here we need the conjugate. We have a binomial in the denominator. So I'm going to change that connecting sign to negative. Oops, just root 3. And I'm going to do a box, a FOIL for the denominator. And we're going to multiply it out. That's 25, negative 5 root 3, positive 5 root 3, and negative 3. So that gives me, these cross out. So that gives me 25 take away 3, which is 22. The numerator, 2 times negative 5 and 2 times negative root 3. Divide everything by 2. And I have my answer. Again, another binomial to multiply. 3 plus root 5, top and bottom. So we need to have 2 boxes here. One for the top and one for the bottom. So we'll do 2 boxes here. So we have one for negative 5 and root 5. And 3 and positive root 5. And then 3 minus root 5 and 3 plus root 5. Alright, let's see if we can multiply these out. So this is for the top. That's negative 15, 3 root 5, negative 5 root 5, and 5. So the numerator is going to be negative 5 plus 5 is negative 10, negative 5 plus 3 is negative 2. The denominator, that's 9 and negative 3 root 5, positive 3 root 5, and then that's negative 25. Oops, sorry. Negative 5, I meant. Root 25, which is 5. So that's negative 5. So these cross out, and then 9 take away 5 is 4. Divide everything by 2, and you have your answer. Here, this is 2 over root 3, and then rationalize the denominator. So that's 2 root 3 over 3. Could you write this as an exponent? So that's k to the exponent 5 over 6. The denominator is the root. The numerator is the power. This is 7x, and the fraction is going to be 4 over 3. How about the other way around? This is going to be the square root of 5x to the power of 5. So the 2 in the denominator means square root. This is going to be the square root of 10v to the power of 5. Could I fully simplify this? This is the cube root of 64. That number 3 times itself, that equals 64, is 4. This is the square root of 49, and then to the power of 3. So that's 7 to the power of 3, which is 7 times 7 times 7, which I think is 729. Let's see. I'm going to use a calculator, cheat thing. No, you don't get a calculator. 343. I was wrong. All right. Can you solve an equation? So first step, we want to isolate the radical, so we're going to subtract 2. So we have the square root of 3v plus 10 equaling 2. We then square both sides, so 3v plus 10 equals 4. We're going to subtract 10, and we're going to divide by 3, so we get the answer negative 2, but then we have to test that answer out to see if negative 2 gives you a good answer or not. So let's see. So this is negative 6 plus 4, negative 6 plus 10, which is 4. Square root of 4 is 2, and then 2 plus 2 is 4, so it definitely works. Left side equals right side, so it's a good answer. So just because the answer is negative doesn't mean it doesn't work. All right, square both sides, and you get 3a plus 5 and negative 1 minus 3a. Combine like terms, we're going to add 3a, we're going to subtract 5. So I have 6a is equal to negative 6, a is equal to negative 1. Again, just because a is negative doesn't mean it doesn't work. So we plug it in, so 3 times negative 1 plus 5, negative 1 and that, negative 1. So I get 2 on this side. I also get 2 on the other side. See how it ends up being a positive value under the square root sign? So that means it works. All right, square both sides, and you get negative 70 plus 17n equals n squared. Make this equal to 0. We're going to subtract 17n. We're going to add 70. And then we're going to FOIL, or we're going to have a diamond. So that's 70 and negative 17. So those two numbers that work are negative 10 and negative 7. Those are my factors. So from negative 10, the answer is 10, positive 10. And then if I plug that in, is that a good solution? And it is. So positive 10 works. The other one is positive 7. Let's see if that works. This one, let's see if I can multiply. 17 times 7 is 70 and 49. I'm just going to do it this way. 70 and 49. Notice how they cross out. So it's the square root of 49, which equals 7. And that's a good answer. So even if I was thinking, oh, what's 70 plus 49? It's 119. But 70 plus 49 is better because then I can just cross out the 70s, makes it easier. So both answers work. Remember, one could work, both could work, both could fail. 70. All right, square both sides. When you square both sides here, we have to FOIL. So that means you have to draw a little box, x minus 2, and then expand it out and combine like terms. So we're going to end up with x squared minus 4x plus 4 and 2x minus 1 on the other side. Make it equal to 0. So we're going to subtract 2x. We're going to add 1. And then we're going to factor with 5 and negative 6. So that's negative 1 and negative 5. Those are your factors, negative 1 and negative 5. So when I solve, the one answer I get is positive 1. Positive 1 is a bad solution because the square root can't equal a negative number. When I plug in positive 1, it ends up being negative 1, and the square root of a number can't be negative. So we cross this one out. We say this one is extra. It's extraneous. The second one, 5, if we test that one out, 5 take away 2, I like. 5 times 2, 2 times 5, take away 1. So that one does work. So one works when you plug it in, and the left side equals right side. The other one is extraneous. All right, turn the page. We're almost there. Last page. We got there. What does A equal? 2. What does H equal? 2. What does K equal? Negative 2. So for a square root, the 3 points are 0, 0, 1, 1, and 4, 2. The H changes the x coordinate, add 2. And we're going to multiply and subtract 2. So the first point is 2, negative 2. The next point is 0. So 1 times 2 is 2. Take away 2 is 0. 2 times 2 is 4. take away 2, and then put those points on. And then draw. Remember, square root looks like a curved arrow. The domain of this one goes from h, so that's 2, to infinity. The range of this one goes from k, which is -2, to infinity. And the end behavior, the right end goes up, and the left end goes to hk. So that's 2 and -2. All right, try the other square root. A is -3, h is -5, k is 4. Write down the 3.001142. So we're going to subtract 5. So we subtract 5 to each one. And then we're going to multiply and add 4. So that's going to be 1 and 2 times -6 plus 4. And put those points on the graph. So -5 and 4. -4 and 1. And -1, -2. Sure I don't pass the points here. There's my curve going down. The domain goes from h, which is -5, to infinity. The range is flipped. It goes -infinity up to 4. And then the end behavior, the right end goes down, and the left goes to hk. So it's -5 and 4. All right, last group to graph, the cube root. So a is -3, h is -1. If I don't see a number at the end that's adding or subtracting, that k is 0. The 3 points for a cube root are 0, 0, 1, 1, and -1, -1. So the first point is going to be hk. The next point, we subtract 1, and we multiply. And then again, we subtract 1, and we multiply and get +3. Adding 0 doesn't change anything. So -1, 0, 0, -3. And then -2 and 3. And it's going to look curved this way, and it's going to curve that way. And you have it. Because a is negative, the s has been flipped. The domain and the range are all real numbers. And then the end behavior, the right end goes down, and the left end goes up. All right, last one. AHK, so A is 2, H is 3, and K is -3, 0, 0, 1, 1, -1, -1. Change each one. So we're going to add 3. We're going to multiply and then subtract 3. So we have 3, -3. We have, what, 2 and -3, that's -1. And then -2 and -3 is -5. So put those on your graph. And again, this is going to go up and right. It's going to curve down. That S-looking pattern. The domain and range never change. It's all real numbers. And then the end behavior. The right end goes up, and the left end goes down. That's it. So I'm proud of you that you finished your work. I hope it helped. I hope you did it first and then looked at the video. I know if you finish this and you work at this, you're going to do great when you take your exam. All right, Mr. G Math over now. Proud of you.